Okay, so people are still joining. So let us wait for few minutes, 2 or 3 minutes. Then we will start today's session. So I hope I am audible live and clear, loud and clear.
Yes, sir. Audible.
Okay, so can anyone respond so I can? Sorry.
Sir, audible, sir. Loud and clear.
Okay, very good. So good evening, everyone. Welcome to the fourth live session of NPTEL course on non-conventional energy resources. So this course is taken by Professor Prathap Haridoss from IIT Madras, and I am taking the live sessions for the course. As you know, this course is available on LPTL platform in recorded form. So whatever interaction you need to make, so it need to be made at this platform with me. So if you have any doubts, any queries, so you can raise your hand or raise your voice anytime. So these videos are also available on YouTube after the session. So it will take few hours, or by the next day it will be available online on YouTube. So you can check it out there also. The PPTs are also available on the given link of Google Drive. So you can access the PPTs there. So you don't need to take screenshots during the lecture. So let us start today's session. So formally, I am introducing myself again. I am Lalit Bharti. I am a Prime Minister Research Fellow in the Department of Physics in IIT Kharagpur. These are my contact. This is my email address as well as my LinkedIn profile. So you can contact me there on my email. Otherwise, you can connect with me through LinkedIn. So I will be available there. So if you have any questions regarding the course, otherwise anything related to academics, so you can contact me there and I will be happy to help you. Okay, there's one query. Somebody is having issue with the link, so I'm just replying him. Please be with me. Okay, so anyways, let's start the session. So this today's session is a lighter session compared to previous, and we will be discussing the some basic types of solar panels and different applications of them. So the next lecture or the next class, we will be introducing the semiconductors and type of semiconductors, the material. So that will be slightly advanced topic, but for today, we will be just having some introduction on solar panels, be it be application in power generation or thermal uses like a solar heater. So let us start with it. So these are just basic some types of solar heaters. As you can see in your notes available online. So we in previous class we also saw how the solar concentrators work. So different type of solar concentrators. So here we are again introducing it again. So this is a solar concentrator in your screen you can see. So this is parabolic type of solar concentrator. So you can see the shape is parabolic here. So basically this is a reflective surface and the focal point is here at the center. So if you imagine a sun here at this point, so all the sun rays will be incident on the surface, this parabolic surface, and they will be reflected to the focal point of this surface, this parabolic dish. So you will get a very high temperature here, and if you have uh, some structure to capture the heat, you will be able to use it as your source of heater, source of concentrated heat. So this is the typical example of your solar heaters at rooftop and also some advanced solar power generation units. So we will also see them. So this is a very fundamental or basic class. So your solar concentrators will be taught in detail in next classes, I guess, but it will be covered. This is another example of the solar reflectors. So you can see here instead of for a parabolic dish, we have a parabolic rod. So it is kind of a parabolic sheet, but parabolic dish, but in a particular direction. So we can see this. This is the horizontal direction, and we have a glass rod here and a copper pipe which can transport heat from the solar concentrator to wherever we need it. So similarly, sun will be at the top, and the rays will be reflected at the focal point of this structure, and this glass tube is used. Inside the glass tube, there is a copper tube, which is a thermal conductor, which will collect the all the heat and transport it. Similarly, this is again the same parabolic dish. This is the parabolic rod. And in these notes, it is mentioned in details that in which direction we should put the parabolic route to maximize the power generation. So let's say if we have this side at west and this side at east, so it should be in such a direction where maximum sunlight will incident on this surface during the Sunday, during the whole day. So if we are placing it in direction of east to west, so sun usually, okay, since sun rises from east and sets and west, so in this particular direction, if you place the structure in this direction, your whole day your sunlight will be incident on the structure. So you will be maximizing the power output of the solar concentrator or solar panel, or let's say solar heater. So this is the solar tower. This is also example of solar concentrator. So usually what we have a receiver here. So does the receiver do? So there are very many solar reflector panels. So these are small reflective panels. So what it does, whenever you have the solar radiation, it reflects the solar radiation to a particular direction. So these are programmed in such a way, so they are usually motorized, so their directions can be changed throughout the day, and according to the position of sun, they will change the direction, and their focus will be always on the receiver of this tower. So the receiver will hot enough, then we have some channel to transport the heat. Let's say either copper pipe, or you can, in advanced systems, you have molten salts. So what the molten salt do? Let's say you have a cool molten salts here. So when it goes into the receiver, it will get heated and it will reach to a very high temperature. Then the high heated molten salts will flow towards your, let's say, your water turbines. So it in contact of water, it will generate a lot of heat, lot of steam, and the steam will run the generator, the turbines, and turbines will move the generators, so we can have the electricity by these solar concentrators. So this is also a typical example, but usually these kind of structures are made in a very large scale. So the plants are, let's say, many meters, or around expanded in few kilometers. This is again the same example, how the focal points have been chosen. So this is the lection 13 is on semiconductors. So semiconductors will be covered in next session. So as I told, this session is quite light. So we will be directly jump into the assignments. So these are the assignments. So the assignments are on the syllabus covered in this week, and some graded assignments are from the last week. So we will discuss all the assignment in detail. So as we discussed in last week, so we will keeping some more time in interaction, as well as you can anytime unmute yourself and interact about anything. So your interaction is always welcome. So if you have any doubts, any queries, otherwise if you want to put your point, you can also just unmute yourself and ask anything. So okay. So we are starting with this question. This question is based on the black body approximation. So we also saw this kind of black bodies in our previous class, and we discussed exactly what is a black body. So the question is a black body absorption radiation. Sorry, a black body absorbs radiation incident on it. So for that we need to understand what is a black body first. So this is a model of a black body. In this again it is shown a black body radiator. So a black body is a good approximation of a okay, this is a good approximation of black body. That is a small hole leading to the inside of a hollow object. So this is a hollow object. Let's say it is inside air only, and we have only a small hole in this direction. So the hole acts as a perfect absorber. So absorber of what? Of any incident light or spectrum. So the nature of the radiation leaving the cavity through the hole depends only on the temperature of the cavity. So
ಹೌದಣ್ಣ
this,
ಅವಾಗ ಮಾಡಿದ್ದಾನೆ ಬಗ್ಲಾಕ್
sorry,
ಬಿಡಿಸೋಳಿದ್ರು
somebody is on mute. So if you
by mistake.
want to,
Sir, it was by mistake.
yes, okay,
No, sir. By mistake, I have unmuted, sir. Sorry, sir.
okay, okay, no problem. No. So this is a black body, and this is a model of that black body. So this hole will act as a perfect absorber. So whatever light goes inside this, it will either absorb here. So it will be either absorbed here or it will be reflected. So whatever reflected light will reflect from this point will incident on the another surface and it will be absorbed again. So the model is such that the idea is whatever light goes inside, it will be either absorbed or reflected. So since there's only a very small hole, so there's very less probability of the light going back out of this cavity. So whole light will be absorbed in this structure. So it is called the black body approximation. So again, defining the black body. So black body is basically a system which can absorb all the incident radiation, whatever incident on the black body. And in the opposite way, again, if you heat this black body, it will emit the same radiation. Because if you incident any radiation, if it is absorbing it, so temperature will increase in the both cases. So if you inversely by yourself increase the temperature, it will emit the radiation. So it is radiation versus temperature. So this statement is true. Yes, the black body absorbs all the radiation incident on it, and it will emit all the radiation when it gets heated. So this is a basic concept of black body. Let's move to the next question. So this is a question on solar concentrator. So it is an advanced structure. You can see how solar concentrator work. So the question is solar concentrator can help raise the temperature of water above 100 degrees. So the statement is quite simple. So if you see this kind of structure, these are small fins like of structure, or these are just the reflectors. So it can made up of glass or any shiny substrate, let's say some shiny metal, polished metal. So what it does, it will reflect the incident solar light in the direction of the concentrator, or this what you call it, receiver. Sorry. So this is the receiver. So whatever, let's say your sun is here. Let's say this is your sun, and light goes in this direction, this direction. So all the light will be reflected towards this receiver. So this is a basic fundamental of the solar concentrator, and the solar concentrator is made in such a way that it can rotate in this direction, as well as the direction, the angle can be adjusted, so it will always be in the direction of sun, directly in the direction of sun. So this is again the same concept, the model. So we have the sun here, this is a parabolic dish, and the receiver at the focal point of this, and whenever the light incident on the dish, it will reflect back to the receiver, and the sun's energy is concentrated 1,000 times into the receiver. So you can guess the power received by the receiver. So it will be a very high, and easily it will go beyond the 100-degree mark. So this statement is clearly true that the temperature of water above 100 degrees, it can go easily. So there are various type of receivers. So this is example of one kind of receiver. This is okay. Now this is we are at the third question. So it says a parabolic concentrator typically does not need tracking because of curved in all direction. So tracking here, the tracking means tracking of sun. So because we have the parabolic structure, this is the parabolic surface. So this is a parabolic dish, and for the parabolic dish, if your sun is in this direction, you need to aim towards the sun. Let's say your sun goes in opposite direction here. Wherever, let's say the condition is here or the condition is here. So in both of the cases, you will not be able to harness the energy of sun because it will not reflect it towards the receiver. So we always need to aim the receiver or aim the parabolic dish in front of sun, or just aiming towards the sun. So that is why we have a motorized system here. So it can change the angle by 360 degrees. Not required to be 360, but let's say 180 degree in both axes. So it is always required to track the sun. So the statement is false that we does not need to track the sun. So this is also a question based on the parabolic dish concentrator. So now we are at the solar panels. So many of us, many of you are working in this field of solar panels. So it is easy to understand by them, but let's explain it in detail. So the question says a glass plate is used on top of the flat plate collector in order to prevent IR radiation from coming in. So first, what is the flat plate collector? So this is the example, the schematic of a flat plate collector. So simply by name, it is in shape of a flat plate. It has metallic conducting strips here. So this example is for power generation, electrical power generation or electricity generation, and this is just cross sections or the different parts of a solar panel. So usually you can understand what is the, we have a backsheet here, then we have a solar panel, and this is the main component of a whole solar panel. This is called solar cells. So these are different cells. So these are connected to with the electrical connections. Then we need to encapsulate it because it should be away from any moisture, any dust, debris. So we need to encapsulate it. So it is encapsulated in both direction. Then there is a glass panel on that, and then a frame. So the solar cells, they are never in contact with water, any moisture, or any dust. So we need to keep it secure. So the idea is, the question asked that we need to prevent the IR radiation. But if you study the solar panel, so, and if you know the fundamentals behind the solar panel power generation, you know that this IR wavelength is also helpful for us to produce electricity. So if it is a photovoltaic cell, and if we have sunlight in visible spectrum, then the IR wave or the IR spectrum is also helpful for us. So we don't need to prevent the IR. We don't need to block the IR. And a glass panel cannot block IR. So the statement is false. The glass plate is used to prevent IR radiation from coming in because the IR radiation itself is favorable, as well as the glass is used to just keep secure the solar cells. So the statement is false. Then let us move to the next question. So the question says, humans and animals give out infrared radiation. So this statement is true because all objects, including human body, animal body, every object, it can radiate infrared. Because if you are, infrared is directly related to the temperature. If you have some temperature, so it will emit the IR radiation. So this IR radiation is also used in night vision cameras. If you have a night vision sensor or the IR sensor, you can see without having a visible spectrum, because IR spectrum is always there. So if you have the night vision cameras, even in night, you can see based on you can see the object if they are reflected by the IR spectrum of light. So this statement is true that humans and animals give out the infrared radiation. So this question is based on our again our black body discussion. So this is the wavelength of most intense part of spectrum associated with the black body. So we are basically talking about this spectrum, this point. So this is the wavelength of the most intense part. So this, let's say, for example, here we have the 483 nanometer. So it is called lambda max. So this is associated with this. So if we increase the temperature, what should happen? So in the spectrum, you can see if you are increasing the temperature, so this is it's 6000 K. If you are, this is the highest temperature. If you're decreasing the temperature, your your lambda max point is shifting towards the higher wavelength. This is higher wavelength here. It is in nanometer. So as you increase temperature from 3000, 6000, your wavelength is decreasing, or you are moving towards the shorter wavelength. It is also given by the Wien's formula. So lambda max is equal to B by T. B is a constant here, and T is the temperature. We can call it absolute temperature. So if your temperature is higher, your lambda max will be less because these are inversely proportional. So if you are spectrum associated with increase of temperature, your lambda max should decrease. So decreases, the second option is correct. So this question is from your previous year's quiz question. So it was the graded quiz, graded question, which So this year also you have some kind of graded question which will be included in your final result. So this is similar to that, but from the previous year. So here the Wien's formula is given and also the value of B is given. So you can keep it in mind. So it can come in your question in your exams for the either the main exam or in your graded assignments. So this question is based on the photoelectric effect. So if you understand the photoelectric effect, it will be a easy question for you. So photoelectric and this kind of these concepts are already taught in detail by Professor Prathap Haridoss in your main lectures. So you can go throughout the main lectures to understand the concepts, and we are just discussing it here. So the question says, which constant helped in understanding the lower wavelength regions of spectral irradiance versus temperature plot at temperature T as well as blank. So we need to understand the what is the photoelectric effect. So let's say we have a metal surface and we have this incident light here. So it is basically you can take as a solar light. So if the light is incident here, and we know that metal have some free electrons, so the free electrons will be ejected from the metal surface. So it is incident light, it will incident on this metal surface, and few electrons will be emitted or ejected. So these are called the photoelectrons. So let's say we have the energy h nu of incident light. So we will have some kinetic energy depending on the energy of initial incident light. And also there will be a work function of the metal surface. So what is the work function? So it is shown here. Let's say EP is the energy of the incident light, which that will be equal to the kinetic energy of photoelectron. So whatever electron is ejected, kinetic energy of that plus work function, that is h nu naught. So this is the minimum energy what is required to eject the photoelectron. Okay. So beyond this energy, if your incident energy is lower than work function, your photoelectrons will not be ejected. And if whatever energy you have, let's say you have 10 units of energy incident of the incident light and your work function is 5, then only 5 will be your kinetic energy. So this is a kind of the consumed energy by the metal surface, and this is the property of the metal itself. So if you replace the metal material, your work function can be differ based on the type of your material. So this is the whole assumption is this photoelectric effect is given by Planck. So that is why the H, this is called the Planck's constant, and it shows the nature of light which is quantized. So why it is quantized? Because we always have the energy in form of some quantum, subquantas. Quanta means it is the packets of energy. So the energy is not discrete. It is always in 1 unit, 2 unit, 3 unit. It cannot be half unit or any integer. So it is called quantized. So this is called the photoelectric effect, and the quantization is well taught, well described by this mechanism. So this photoelectric effect is also a reason of getting Nobel Prize. So the photoelectric effect itself is very important mechanism or important phenomena in material science, in physics, or in any relevant sciences stream. So it is the next question is again on the quantization of light or the energy. So the question says particle of light is known as blank and it can only be possess energy h nu blank and h nu. So again from our last discussion, let's say we have energy of a quanta. So this quanta is called photon. So the particle of light is known as photon. Photon means the minimum unit of the, you can say, the quanta of energy or the quanta of light. So this is the smallest unit, and always the energy will be in multiple of this. So your quanta is having h nu energy, so you will always have energy in form of nh nu. So n can be any integer 1, 2, 3, 4 or anything, but it cannot go beyond below 1, or it cannot be 0.5, or it cannot be 1.5, it cannot be 2.5. It will be always in integer because this is the smallest unit of energy and quanta cannot be divided furthermore. So we have 4 options. So all photon is correct for all, but we have option like 2 h nu, 3 h nu, 2.5 h nu, 2.5. So 2.5 h nu cannot be correct. So only options of 2 h nu and 3 h nu are correct. So these both are correct. Oh, sorry. So the options 2 says it is phonon. So phonon is not the quanta of energy. So phonon is some advanced form of energy in terms of vibration. So phonon is the quanta of vibration. So in physics, people are very well aware of what is phonon. But if you are not aware of that, you just consider the phonon is the quanta of vibration. Then come to our fourth question. It says the full solar energy spectrum is consistent with blank and the visible region of this lies between what? So we have already talked about black body. So what is a black body? Which can either absorb all the whole spectrum of light, either it can emit the whole spectrum of the radiation. So this is the whole spectrum, including radio waves, microwaves, IR, UV, visible, X-ray, gamma rays. So if you have a black body, it can absorb all these light, all this spectrum, whole spectrum. So the full solar energy spectrum is consistent with this black body radiation. So there's nothing called brown body radiation. Always it is black body radiation. So that is correct. And the visible region of the lies between what? So this is the visible region. You can see the 7 colors here. So it lies between 400 to 700 nanometer. So you just keep in mind the range of your visible spectrum. So in simple way, it is 400 to 700 nanometer. So as you go higher in frequency or lower in wavelength, so you have the UV and at the right side you have the IR. So your option fourth is correct, that your visible region is between your IR and UV. So the overall the fourth option is correct. So okay, that is correct. Now again the question is on flat plate collector. So this is the question says the flat plate collector to harness solar energy requires blank conducting sheet made of blank material. So first let us understand. So this is a example of those. This is the schematic of a flat plate collector. So what does it have? First, it is having this glass cover. Then copper tubes. So the copper tubes, what the copper tubes are doing? So copper tubes are transmitting whatever your heat collected by the solar panel. So it will collect and transmit the thermal energy or heat. So then you have the absorber plate beneath it and thermal insulation just to insulate the copper pipes and the solar panels from the below the surface. And we have the casing. Similarly here we have the fluid pipes. So in this case we have copper tubes. So usually these are filled with some liquid, some fluids, so which can flow throughout the solar collector. So we have the solar radiation here, this transparent screen here, then some fluid tubes in which we have some fluid and thermal insulation. So the question basically says the flat plate collectors to harness solar energy requires what? Electricity, thermally, this conducting, thermally conducting, magnetically conducting. So we know that there is nothing to link about magnetically conducting. So we have options of thermally and electrically conducting. So since we don't have the photovoltaic cell here, we are not harnessing electricity. So we are just looking for the thermal or the heat or the thermal energy. So it should be thermally conducting. So the collectors should be thermally conducting, which is example is copper tube or any kind of other tube which is having fluid inside it. So the thermally conducting is correct. So thermally conducting sheet made up of what material? So it can be either copper or it can be any other material, any other, but it should be highly thermally conducting. So it should be a metal. So metal or copper. So in metal, copper is very well used. So it can be any another metal also, but copper is mainly used due to its high thermal conductivity. So the option 2 and 3 are correct here. So let's take the next question. It says the metal sheet in solar energy collector is coated with black color. Okay, so below there are three reasons. Reduce the reflection of sunlight, increase the absorption of sunlight, protect from the environment. So if you see, this is the basic sun and this is our object and it is absorbing the sunlight. So it is coated with black color because we know that black color is a very good absorber of solar radiation, because black color will absorb. So it is similar example to a black body. So it can absorb the whole visible spectrum. So black means why we have color of a material, because it absorbs some spectrum of light and reflect some of it. Let's say you see something is green in color. So what it will do, whenever a light is incident on it, your corresponding color or the opposite color of green, it will be reflected back from the surface of the object, and only the green color, okay, sorry, the opposite color is absorbed by the surface. Let's say the red is absorbed by the surface and only the green light or the green color is reflected back. So that is why we can see that the object is in green color. So what happens in the with the black color? So it absorbs the whole visible spectrum. So that is why we use the black color or black color coating as a good absorber. So yes, it is a good absorber of sunlight, and it reduces the reflection because it is simple that if it is absorbing most of the light, then the reflections are very low. So the option first and option second, these are correct. And there is nothing to do with the protect from the environment, because the system is already inside the, these are already encapsulated well, and we have a glass, very thick glass sheet above all the system. So it is already safe or protected from environment, be it be any debris, be it be any dust, or be it be any water content. So we don't need to protect by just using this black color. So option first and second, here the option third is correct. So let us where was at the seventh question here. So the seventh question says the glass plate on the solar energy collector setup. So we have three statements. Keeps the visible radiation stuck between the metal sheet and the glass. Reduces convective losses. So we have to understand what is conduction, what is convection, what is radiation. And third is reduces IR radiative losses. Okay, so let us see. The glass plate on the solar energy collector setup is having what of these statements. So we have three types of energy transfer: conduction, convection, and radiation. So in a simple way to understand, conduction needs to having direct contact. So for this example, this is a let's say a pot, and we have water inside, and it is heating by a inductive heater. Let's say this is an inductive heater or any kind of heater, let's say, and the water molecules, they are getting heated here. So for conduction, you need to have direct contact. If your hand is touching the pot and if you are feeling that yes, the pot is hot here, so that is why you are in conduction with the system. So for conduction, you need to have contact, but there is no flow of mass because your hand is here and the handle of the pot is here and you are just touching it directly. But in convection, convection usually happens in gases or liquid. So in convection, what happens? There is a flow of media or flow of the material. So at the below, the temperature is high. So you know that if the temperature is high for water, the density decreases, and due to the buoyancy forces, the hot water particles or the hot water molecules, they will go up at the upper portion, and the cold water, due to the denser molecules, they will come towards the hotter region. So this is basically movement of the water molecules. So movement of large number of particles in the same direction occurs due to the difference in density. Cycles occurs while temperature difference exists. So this is basically happening in gases and liquid, and this is example of convection. And the radiation, when you don't have the direct contact of two objects and the energy is transmitted in form of radiation. So in form of electromagnetic waves such as light, microwave, and infrared, and all objects radiates energy can transfer the energy through empty spaces. So this is example. If you have a hot plate here, so if your pot is not in direct contact, but still it is getting heated. So it is simple. Simple example is if you stand near a fire. So although you are not in direct contact with the fire, but you can feel the heat of that. So that is basically due to the electromagnetic waves in form. So there it is in form of light as well as the infrared radiation and other waves. So these are types of energy transfer. So for a solar energy collector setup, you can see here. So let's say this is your glass plate and solar radiation is here. So we are having some reflection. So we like to minimize the reflection, but still we get some reflection. So our statement one says that keep the visible radiation stuck between metal sheet and glass. So this is not correct because the top plate is basically just protecting our solar panels or solar cells, or let's say whatever system we have, the glass tubes, the copper tubes, and all that. So it protects it, but it cannot keep only the visible radiation stuck between the glass sheet and glass, because there's also higher radiation and it cannot hold it as mentioned in the statement. It can only reduce the losses. So whatever, let's say you have some convection, but it will not let the whatever gas is inside the chamber, it will not let the heat loss by convection as well as by radiation or by IR radiation. So statement 1 is not correct, but statement 2 and 3 is correct, that yes, it reduces the different type of losses. So the main aim of the example is to understand the types of energy transfer, different types, and how we can link these types to a solar energy collector setup. Then we have the question, next question is over 8. So it says, the ability to pick up heat is limited by the area of a flat plate. Okay, so this is a kind of flat plate. Flat plate collector exposed to the sun. It can be increased by replacing the tube by fins or mesh. So, okay, so these are, it is a flat plate which is having area A times B. So that is the small a times small b. So that is the area. And here we are introducing some fins like structure. So the reason one is fins and mesh have more surface area to the tube. Fins increase more air resistance. So statement 1 is true, that because here all, if you have this kind of small section, they have all in same direction. So if you try to change the dimension or the structure of the flat plate, your area will increase. So that is why you use this kind of parabolic sheet, or if you use different types of fins, so the fins can be at the slight angle. So by that angle, your surface area will increase. So the statement 1 is correct, more surface area than tube. But it doesn't help you in increasing your air resistance. So if you have fin, your air resistance will decrease only, but it will not help. And air resistance is not that much considerable here. We are looking more about the ability to pick the sun's heat. So that is why these kind of structures, either the parabolic structure or the fin-like structure, is considered.
Excuse me, sir. Hello, am I audible, sir?
The option 1, the fin and mesh have more surface area than tube. That is why they are considered.
Hello, sir. Am I audible?
So this is again the, hello.
Sir, am I audible?
Yes, yes.
Sir, in question number 8, hold fins increases more air resistance. Hello.
Yes, yes.
Sir, when we increase the area of fins, definitely it will resist the air.
But because in the fin structure we have the empty spaces here. Fins means what? Fins mean they are small sections, so they can be put in some angle. So similar to our, let's say, I'll just show you. Yes. So here we are using the fins here. So the aim of the fins is, because these are at the slight angle, the energy, the reflected sunlight will be more here, and they can be used to concentrate at the receiver. So that is why we are using fins here. So similar fins or the curved surface. So similar concept can be followed here. So the question says the ability to pick up the heat is limited by the area of the flat tip collector exposed in the sun. So we need to increase the ability by replacing the tube with a fin or mesh.
Yes, sir.
So the fins mesh will definitely have the higher surface area and increased more air resistance. So first thing is the air resistance is not that much considerable here because the whole system is already encapsulated. So the air resistance will not play that much role, but we are just trying to increase the surface area where the sunlight will be incident. So that is why we are considering the surface area mainly, and the fins increases more resistance. We are discarding this option. Okay. So at our next question, it is again based on our parabolic dish reflectors. So it says that parabolic dish reflectors are in the shape of either concave or convex mirror, which use the idea of concentrating solar light at blank focal point. So these are made up of highly polished stainless steel and aluminum surfaces. Okay, that is correct. This is the surface. So by understanding, we know that what is concave and convex. So this structure is clearly a concave structure because in a concave structure, your focal point is inside the structure. If you have the convex, let's say this side, your light will not be focused on a single point. So it will be reflected in all other directions, but it will not be collected. It will not be focused at a single point. So that is why we use the concave structure, and the parabolic dish reflectors, they have the concave surface, similarly here and similarly here. So we have the shape of the mirrors are usually concave, and which uses the idea of concentrating solar energy at how many focal points. So yes, the focal point is always a single focal point because let's say if you have a concave structure, there will be only a single focal point. Otherwise, you need to modify the structure. So that is why we have always have a single focal point. So in this parabolic strode type or just this structure, the focal point is not a point but a line. So you can take as a focal line. Here also a focal line where all the solar energy is concentrated. So we can put a tube here. So the whole solar spectrum or solar power that is concentrated on the tube. And if we have some fluid there, the temperature will increase as the fluid flow throughout the tube. So the option 2 is correct because the structure is the shape of the mirror is concave and the solar energy is focused on a single focal point. So this 10th question is having the similar thing. The question says a single focal point parabolic dish collector is said to be what? So the flat plate collector is not correct because it is not a parabolic dish. Non-imaging concentrator is also not correct. Throw collector, we saw already what is throw collectors. So for a single point parabolic dish, it is called the imaging concentrator because it is similar to a image is concentrated at a point in case of a lens. So it does the similar job just in case of your solar light. So a solar
So,
parabolic dish collector is called the imaging concentrator, not the flat plate, not the non-imaging, not the throw collector.
so what is the throw collector?
Yes.
So what is the throw collector? Throw collector.
Throw collector we so this is the throw collector. So it is having a horizontal axis instead of just a parabolic. Parabolic is something like I saw it. Parabolic is something like this. So it has a single focal point. And throw collector is something like this. We have a central receiver which is having a let's say which is a tube. So we use this kind of structure in solar heaters usually. So question 10 was done. So then we have few questions based on our previous quiz. So it is based on our last quiz. So let us see. So we have something. Let me see. So what is the
एक्सक्यूज मी सर
difference?
सर
Okay,
एक्सक्यूज मी
you.
सेवंथ नंबर एक बार रिपीट कर दीजिएगा सर
So which one?
हेलो सेवंथ नंबर
Yes.
क्वेश्चन
7th. Okay.
हाँ सर सर इसमें
7th
जो है
number
ना
is
जो बोले कि आप बोले कि ये मतलब इसमें तो बताया गया था सर कि वीडियो में कि जैसे वो रेडिएशन आता है और वो विजुअल लाइट को स्टक कर लेता है तो 1 नंबर सर कैसे गलत हो गया वो नहीं समझ में आया हमको
keep the visible radiation stuck between metal sheet and glass. So it should not be only visible radiation because whatever radiation you are getting, the IR is also there, no? The whole solar radiation. So you need to keep first, it will be slightly reflected, but the main aim of the glass plate is to just reduce the losses. First, it will protect the whole solar panel and it will reduce the losses by convection radiation. So both two options are clearly correct, but the first option is not only the visible radiation. Okay, so it should be the whole radiation. If you keep the whole solar radiation, then this should be correct.
ठीक है सर सर जैसे एक्सक्यूज मी सर
Yes.
सर वो ग्लास का कुछ प्रॉपर्टी होता है ना जैसे कि जिस तरीके से अचार बनता है उसी प्रॉपर्टी को लेकर के ये सोलर प्लेट बनाया गया है ना सर
जिस तरीके से क्या बनता है
जैसे अचार जैसे बनता है सर उसी का प्रॉपर्टी यूज करके बनाया गया है
नहीं मैं एक्चुअली आई couldn't understand अचार बनता है मींस
Actually, he
जैसे
wants to say
शीशा का अचार
it
जैसे सर
is
शीशा में
energy.
व्हाट सर क्या बोले
वन बाय वन बाय
जैसे अचार जैसे शीशा का वो केतली या कोई जैसे जार होता है उसमें नींबू वगैरह सब डाल दिया जाता है तो वो अचार बन जाता है सर तो उसी का प्रॉपर्टी यूज किया गया है ना हेलो उसी के वजह से वो भी तो होता है
यस सर सो इट कैन बी टेकन एज अ सिंपल एग्जांपल कि जो अचार बनता है उसमें भी आपका रेडिएशन एक बार जा रहा है इनसाइड एंड उसके बाद वो उसके अंदर स्टक हो गया उसके बाद जो बाहर आ रहा है वो उसको लॉसेस को कम कर रहा है ग्लास प्लेट तो जैसे ग्रीन हाउस इफेक्ट होता है जो ग्रीन हाउस इफेक्ट में हम देखते हैं हमने लास्ट क्लास में डिस्कस किया था ग्रीन हाउस इफेक्ट में भी ऐसा होता है जैसे कि लेट्स से यहाँ पे ये एक चेंबर है इसको एक इंस्टेड ऑफ सोलर पैनल लेट्स से ये एक चेंबर है ऊपर एक ग्लास प्लेट है तो ग्लास प्लेट क्या करेगा जैसे सोलर रेडिएशन आएगा some part will be definitely reflected and some part will be absorbed but some part will be go through inside the chamber अब चेंबर में जाने के बाद कुछ पार्ट रिफ्लेक्ट होगा सो लेट्स से ये रिफ्लेक्ट हो रहा है इस चेंबर से सो ये जो ग्लास प्लेट है ये उस पार्ट को वापस अंदर भेज देगा सो ग्रेजुअली क्या होगा मल्टीपल साइकिल्स में इस चेंबर का टेम्परेचर बढ़ता जाएगा तो ये ग्लास प्लेट एज ये होता है जो हम बोलते हैं ग्रीन हाउस इफेक्ट तो ग्रीन हाउस इफेक्ट में यही होता है जैसे कि कोई ग्रीन हाउस फार्मिंग करते हैं तो ग्रीन हाउस फार्मिंग में भी अगर आपको टेम्परेचर बढ़ाना है उस एरिया का तो आप एक शीट रख दीजिए ऊपर सो वो क्या होगा कि जो आपके लॉसेस है उसको कम करता जाएगा और आपका जो चेंबर का रेट टेम्परेचर बढ़ता जाएगा सो दिस इज सिमिलर टू दैट और जो आपने बताया जो एग्जांपल अचार बनाने वाला वो भी दिस काइंड ऑफ सिमिलर टू दैट
जी सर
so somebody is asking in parabolic throat collector we have linear concentrator whereas in parabolic dish collector we have point concentrators yes so Prashant That is correct. So again, I am just showing both of these. So this is a uh, parabolic dish collector. So we have a single focal point. It is like a, if you have seen this dish TV antennas. So this TV antennas, what does it do? It will collect the solar energy or the signals in that case of dish TV and focus on a single point. So we will get the signal at the single point. और जो throw collector है, in that case, usually have a horizontal tube. So ये tube, it is usually used in solar heaters. So solar heaters में क्या होगा? Yes. So solar heaters में there is a fluid, it is the inlet and that is the outlet. So तुम्हारा cold water जो है, it will go inside the tube and by the heating of the sun, your water will get heated and you will get a warm water at the outlet. So that's why we have the tube-like structure. So that is called the reflective throw type concentrator. And in parabolic, we have a single point. So I hope this is you understand the point. So we have 5 more questions on the previous week's discussion. We have 10 questions. So let us take a break of 10 minutes. So I will get some water and we will start it around 8:20. And we will go through these 10 questions and then we will have a follow-up interaction session. So you can ask whatever you want to in that session.
Yes, sir. 8:20.
Okay. Yeah, 10:20 should be fine. Sorry, not 10:20, 8:20.
Yeah, 8:20. Yes, sir.
In 10 minutes, around
Okay,
9
sir.
minutes. Okay.
Okay, sir.
Okay, so let's resume the session. So we have 10 questions for related to our previous quiz or the previous week course content. So we'll quickly go through it. So we already discussed the GDP and the effect of GDP on energy consumption. So the question is given that based on gross domestic product or GDP and the energy consumption of the state, it is seen that as the GDP increases, people becomes wiser, so the energy consumption of the state decreases. So that is not correct because it doesn't need to. The GDP doesn't reflect the wiseness of a person, and the energy consumption doesn't decrease. We know that as the GDP increases, the energy consumption is increasing only. So similar kind of questions we discussed in our previous class. So that is understandable easily. The second option says the increasing GDP is typically associated with the increasing energy consumption. Yeah, that is correct. The more GDP requires more energy, so that is correct. Then it directly related to the higher population. So yes, if you have the higher population, your energy consumption will also be higher. Then it is typically associated with increasing industrial development. So that is also correct. If you have more industrial development, your energy consumption will be higher and your GDP will be higher. So option second, third, and fourth are correct. Then the second question is two states A and B consuming the same amount of energy per year. So this is our A, this is B. The energy consumed is equal for both of the states. State A is 1.5 times higher the population of state B. So for example, if we have the 1,000 people in state B and we have the 1,500 people in state A. If residentials are automotive power consumer per capita, uh, if residential and automotive power consumption per capita is the same for both states, which of the following statement is most likely correct? So per capita we also discussed. So what is per capita energy consumption? So whatever the energy consumption, total power consumption we have, if we divide by a unit or divide by let's 1,000, so we will have the per capita energy consumption. So statement 1 says both state A and B are equally industrially developed. So we cannot say that because we just know that it is A and B are consuming same amount of energy per year, but we don't know the population and the uh, energy required utilized by the population of that state. So we cannot say that A and B are equally industrially developed. State A is more industrially developed than state B. So if state A is more developed, then the energy consumption will be higher for per capita. So because we have 1,500, so your per capita energy consumption is lower for state A. So again, the statement 2 is not correct, but statement 3 says state B is more industrially developed than state A. So you can say that even having lower population of 1,000, the energy consumption is equal. It means the per capita energy consumption is higher for B. So as you know, the per capita energy consumption is directly related to the development of the state or the GDP. So the statement is correct. The statement third is correct. So only option third is correct. Then we go to the why does the presence of carbon dioxide gas in the atmosphere affect the global temperature? So we already discussed this. What is the effect of what is the role of CO2 in atmosphere? Why how it helps in increasing the temperature? It is similar to the greenhouse effect. What is the greenhouse effect? We saw in the last class. So this is typically a CO2 molecule. So why CO2 is so much important in this case? because these are higher active molecules. So what it happens when the photons are incident in this, it will undergo some vibrations and absorb this higher energy. And after the absorption, it will also emit the energy in form of radiation or thermal radiations. So it is a cycling process. So that is why the presence of CO2 is important for maintaining the temperature in the atmosphere. But if we have the higher level of CO2, the global temperature will increase. So the options are because it absorbs the higher wavelength radiation. So that is correct, because it absorbs the shorter UV radiation. But that is incorrect because these are not UV active, or UV light doesn't produce the vibrations in the molecules. Only the IR region of spectrum can induce this kind of vibrations. Then option third is because CO2 molecules have exothermic reaction in the air. So that is not correct because they do not give any heat. This is just due to the vibration, and because CO2 molecules give out heat in the presence of oxygen. So that is not correct because it is not having any reaction in the atmosphere. The CO2 is intact in form of CO2. It is just only the different type of stretching of bonds or the bending of bonds. So only option 1 is correct. So it is the reason why we need to limit the CO2 levels in the atmosphere, because it is increasing the global temperature due to the greenhouse effect. Then let's go to the fourth question. It says a planet is at a distance of 149 million kilometers from the sun and has a twice of radius of Earth. So this example is, the planet is at distance of 149 million kilometers. Let's say this is your 149 million kilometers and has a twice of radius than the sun. So if this is your Earth, it is having two radius is, if it is R, it is having 2R. So the options are will get the same power as Earth. So if you have the radius R here, so your area will be 4 pi R square, and your area will be, in this case, the larger planet, your area will be 16 pi R square. So in our previous class, we saw that area is a important parameter here. If you have the higher area, your sunlight or the power collected by the planet will be higher, because the sun is emitting the sunlight or the power radially outward in all direction in 360 degrees. So more your area, more will be the power collected. So the option 1 is not correct. Will get the same power? No, because the radius or the area exposed is higher for the planet, for this planet B. Let's say B. So option 2 says will receive more power than Earth. So that is correct, because the area is higher, then the power collected will be more. Will receive more intensity than this Earth. Okay. So intensity depends on the distance between sun and the planet. So whatever intensity you are getting on Earth, the similar intensity you will get at the other planet if it have at the same distance. So intensity will remain same. The fourth option is will receive same intensity as the Earth. So that is correct, because it will having the same intensity. Only the power collected or the power incident on the planet will be different. So the option 4 is the question 4 is clear. So then we have the question 5th. It says a normal human being cannot see the things in complete darkness because I see the objects only through which light. So we know that our eyes can sense only the visible spectrum of light. So if this is the whole spectrum, only this region from 400 nanometer to 700 nanometer, that is, our eyes are sensitive to this spectrum or this region only. So your retina is sensitive towards visible light only. So only our option 1 is correct, that reflected visible light. Otherwise, all IR, UV, we cannot see things in IR or UV. You can just sense the visible light. So this is a question 6. The majority of reaction going on inside the sun are, so we have already seen which kind of reaction happens at the sun. In the previous class we discussed. So this is not the nuclear fusion. This is nuclear fusion. Fusion means two different molecules are fusing together to make a larger molecule. Let's say we have two different isotopes of hydrogen. Hydrogen here, it is tritium and this is deuterium. These are fusing together, making a helium, which is also called as alpha particle. This is denoted as 2He4 and one neutron. And the whole mass of the product is lower than the reactants. So some mass will be converted into energy. So if you have excess energy, so that is called the exothermic process. So this is a typical reaction. One is deuterium, this is tritium. It is producing helium 2He4 plus neutron plus some energy. So the energy means it is exothermic. So option 4 is correct. It is not endothermic. So third is not correct. Then one, it is nuclear reaction, correct, and it is fusion reaction, that is also correct. So option first, second, and fourth are correct. Then we go to the seventh question. So it is a simple question, and as we know, and we discussed this earlier in last, I guess, 2 classes. So this is the structure of our atmosphere, different layers. The question is asking the maximum mass of Earth's atmosphere is in what? So this is troposphere, the lowest or the nearest atmosphere to the planet, and most of the activity happens here only. So all the low-lying jets, the hot air balloons, you can say all the atmosphere, all the weather, the clouds, all the things happens in the troposphere. So we live in the troposphere itself. So most of the mass is concentrated at the troposphere, because as you go up, your density will increase or the mass will decrease of the layers. So most mass lies in around 80% of the mass of the atmosphere lies in the troposphere. The troposphere is correct. Then this question. So this question, I guess we are encountering it at the third time. So it is just how we calculated the what will the duration of the sunlight required on the surface of the Earth to fulfill the total energy demand of 1000 exajoules. So we calculated it previously also. So I'm just quickly revising it. So this is your Earth, this is your power, this is the sun, and this is the radius, or basically the distance between sun and Earth. So the sun will emit energy readily output. So what intensity what will get? So it can be achieved by this formula. It is using the distance of the distance of the radius of the orbit of Earth. Then we will calculate the what is the area of the Earth disk. So this disk is visible. So by the radius of Earth, which is 6,400 kilometers approx. So we'll get this area. Then what the energy received from the sun by each year. So it is in terms of joule per second or watt. So in for joule, we will convert from second to minute to hour, then day to year. So this is the total energy. And then we know that 500 exajoules are the total humankind uses, and we are getting 5.5 million exajoules. So we need roughly 0.79 hours. But if we take the 30%, the energy will be lost by the reflection. So only efficiency is 0.7. So we'll take around 1 hour to get this amount of energy. So 500 exajoules is required for 1 hour, and for 1000 exajoules we require 2 hours. So it is just showing the magnitude of energy or the power achieved by sun. So it is showing that the whole humankind, if you need 500 exajoules per year, so only 1 hour of your solar energy or the solar power is enough for running whole world or the whole earth, all humankind stuff for 1 year. So this calculation just for your reference, how much solar energy is available to the earth. Then question 9, it is it is a repetitive question. So CO2 levels will keep on climbing at the same pace even if usage of all conventional sources of energy is reduced to 0%. So since we know the CO2 levels are increasing due to the non-conventional, the conventional sources of energy. So we are using the petroleum-based or the fossil fuel-based sources mainly. So that is why the CO2 levels are increasing, and especially from 1980s to 2020, since due to developments and usage of conventional energy sources, the pollution is increasing. That is why the CO2 levels are increasing. So if we can move towards renewable and clean energy sources, your CO2 levels should not increase. So the statement is false. If you are using the clean energy sources, your CO2 levels will stop increasing. So the statement will be false. Then the question 10 says, based on the Kardashev scale, we are in not yet the category, indicate the closest category below which we are of the civilization, since our ability to harness harness blank is still nowhere near the definition of this category. So first we need to understand what is the definition of Kardashev scale. So the scale is a method to measuring a civilization's level of technologically advancement based on the amount of energy it is able to use. It was first proposed by the Soviet astronomer Nikolai Kardashev. That is why we call it the Kardashev scale. So it shows the how for our civilization, or let's say for our humankind, how much energy or how much technology we have to harness the total amount of energy which is able to use. So based on this scale, we are at different types. Type 1 civilization planetary. So it is the civilization is able to harness all of their planet's energy from the parent star. So parent star is sun. And this type has control all over the entire planet, natural forces such as the volcano and the weather. So even we are not at this type 1 because we are not able to harness all of the energy from the sun, and we have no control on the natural forces like volcanoes and weather. So we cannot say that we are even at the type 1 civilization. So the statement says, based on this scale, we are not even at the type 1 category of civilization of our ability to harness solar or wind. So we are getting the energy from the star. So it is referring the solar. So solar energy is still nowhere near to the definition of this category. So if we can harness all of the solar energy which was calculated here, per year we are getting 5.5 million exajoules. So if we can utilize this whole energy, then we can come in the first category. Otherwise we are not even in this category. So this is just to understand that how much solar energy we have as having as being on the planet Earth, and how much we can harness. So these 10 questions were from the previous quiz or the previous course content. So most of the contents are covered now for this session. So we are open for any kind of interaction now. So if or any questions, you can just ask here. I will be here till our scheduled time of 9 p.m. If you don't have any queries, you can leave the session. Otherwise, you can ask. I will be here till 9. So again, I'm just reminding you, this course is available. These recorded videos are available on YouTube. The YouTube links will be shared to you. Otherwise, if you have the previous link, the videos are available on the same channel in the same playlist.
Thank you, sir.
Sir, thank you, sir.
Thank you for
Thank you, sir.
attending the session.
Wonderful session. Really, it was great.
Yes, yes, Anand.
Sir, like week 1, sir, assignment I have not given, sir. It is showing that due date of submitting assignment has passed, sir.
Yes.
So is that okay, sir, or shall I continue with like week for third, fourth, fifth? I'm attending. First and second week I have not given, sir.
So which the assignments is which need to
Yes,
be
sir.
submitted, right?
Yes, sir.
So
Correct, sir.
if the date is over, you can still, is it available to submit now?
No, sir. I cannot give again, sir.
Yeah, that is why, because the due date is it is automatically set. So if you miss the date, it is not available. So that is okay. You can skip it now. So
Yes, sir.
it will have some weightage in your final results, but 1 week is okay. It will not affect a lot. So you
So
can
2 weeks,
do the,
like
sorry.
this, I passed with the 2 weeks. I missed out, sir. Actually, after that, I'm giving in continue section, sir. Week third, fourth.
Okay, so you can, whatever you miss, that is okay. You can continue from the next week, because it will have some contribution in your main results, but it's
Okay,
still main contribution is from your exams.
okay, sir.
So whatever you missed, you can continue with the available assignments.
Okay, sir.
Hello.
Yes,
Hello. Am I audible?
yes, yes, you are.
सर मेरा एक क्वेश्चन ये था कि ड्यूरिंग द वीडियो सेशंस एक क्वेश्चन था कि ड्यूरिंग द समर विंटर एंड ड्यूरिंग द रेनी सीजन जो प्लेट कलेक्टर होता है उसको डिफरेंट डिग्री पर रखना चाहिए. तो कैन यू शेयर मी एट द ड्यूरिंग द विंटर एंड रेनी सीजन व्हाट इज द एप्रोप्रिएट एंगल for the collecting more energy?
So you are asking from the last session, right?
Yes.
Okay. So you cannot say a global proper angle, because it also depends on your position, in which state
Yes,
or
sir.
in which country you are situated. So it also depends on
Geographical
the
location.
geographic. So yes, so basically the geographical location. So that makes a lot of impact in that. So
Okay.
otherwise, so there's some, I remember from my classes. So there's some calculation or just angle of sunrise and sunset. So you need to follow that angle. Okay, from east to west. So you need
Okay.
to follow that angle, and depending on your location and whatever time you are in, which time zone you are, so you can set your what you can rotation of your solar panels or whatever mechanism you have. So you can set according to that. So it depends on your geographical position and which time zone you are having and direction of your
In the lecture during the summer, you can put your plate. It is into the horizontal form, means 90 degree exactly, 180 degree. Sorry.
yes, yes.
But
So because
for the India,
in this,
for the consider as India, right? Then what is appropriate for winter and rainy?
I don't know exactly what should be the angle, but it is for India. Even for India, it depends on the your position. But because in the different sessions, direction of your sunlight changes. So
Okay.
because your position of your planet, the planet Earth is changing with respect to sun slightly, so your position changes. So I don't know the exact angle, but
But range, in range, I think.
range, I guess.
Sir, in
So what
lecture,
can I? Hmm?
sir told during a winter,
Yeah.
somewhat we incline towards the south.
Yeah.
Yes, yes.
But
But
what is it is range?
exact
Otherwise, it
angle
is
is
between
maybe
40
in a
to 60, yeah, 30 to 60, yeah, anything.
Yes, that there is some particular range that should be given in the notes of whatever notes are provided. So I don't know the exact range, but
Okay.
there is a range of that which differs with the season to season, like winter to summer.
It's okay. Thank you.
Yes. So as I always say, you can also introduce yourself. So like where you're from and what you are doing. So it can be a good interactive session.
Myself, Prerna Shah. I am from Bharuch, Gujarat,
Okay.
and I am an assistant professor in Government Engineering College, Bharuch.
Good. So we are a good audience this time.
Okay,
So
thank you.
if nobody have any, if you don't have any queries, you are free to leave. If you have any queries, you can please ask.
sir. One thing I would like to say.
Yes.
Actually, a lot of questions we have done practice during the session, but I
Mm.
think still, if some more objective questions or multiple select questions, if available, uh, as per week session wise, we can say week wise, so it will
Mm.
support for final exam for practice purpose.
So yes, I understand your point. So the main thing is these questions are based on the course structure itself. So
Yes,
whatever questions are being asked in previous year quiz or your assignments or your exams, so I'm taking those questions only.
yes,
So
yes.
by this question, you can cover your exam pattern as well as your exam this content. So that is why I'm taking some questions are yes really easy, but it is
Yes.
due to the course because your audience is from graduation students to, let's say, you are the assistant professors. So this course is a very wide course. So that is why some questions might be very easy, but it
But
needs
some
to be
questions are
covered.
very
That is why.
difficult. After study, after looking the lecture, every lecture I have listened and make the notes. But still, sometimes we have some problems by solving the assignments.
Yes. Yes, it
Because
happens.
yeah, we think in different way, analyze the questions.
So this issue is actually a very genuine issue in case of these IIT systems. So what happens in the university system? You have a certain committee is making papers or assignments, and so everything is according to some norms, some rules and regulations are there. Okay, this is your course content, this is your syllabus, your questions should be like this. But in the case
Yes,
of
please. Fine.
you,
Please.
in this course or even in some exams in IIT, when they take exam, the question is totally depends on the professor. So in which way they want to ask the question, they ask. So sometimes they do not correlate with the syllabus, sometimes out of syllabus, sometimes very different from the syllabus what they have taught. So it happens. So it is a typical
Yes, sir.
problem. So that is why what I'm trying to do, I'm not taking questions from my will. If I take questions related to solar panels, they uh, may not be relevant to the course content or your main assignments or your exam. So that is why I'm taking the previous year questions or the last quiz questions or this kind of questions, so they can correlate well. So that is why I'm not taking questions from myself. I'm just taking those questions, their own question. So these will be more
Yes, sir.
relevant in your exams.
Thank you, sir.
Yeah, thanks a lot. So usually I make this kind of announcement. So you are always welcome to connect with me on the LinkedIn platform also. So this is my profile and this is my LinkedIn profile ID. Otherwise, you can search with me this name and this profile. So you can connect me there on LinkedIn. So we will be connected, and whatever any kind of discussions, if there, we can have that.
So any contact number? We can ask through WhatsApp sometimes.
Sorry.
Contact mobile number.
Okay, so I can drop it in chat box, so you can get it from there.
Okay, sir.
So I dropped it in chat box. So this is my contact as well as my WhatsApp number. So you can contact me there also.
Thank you, sir.
Yeah, welcome.
Sir, like this is my first session in this SWAYAM, sir. Like
Okay.
exams will be conducted in any center or like uh, we can give it from home, sir. Like.
So I guess the exam will be offline at a
Yes, sir.
center. Means maybe online, but at a center. So usually it is at the center for all NPTEL courses. So
Yes, sir.
the main thing is I'm not connected to the exam things. So we are assigned the interaction part, but as
Yes.
per my knowledge, the exams will be for the registered students who have paid the fees and who are properly registered in
Yes,
the
sir.
course. So the exams will be
Yes.
for offline at some center. And otherwise, if
Yes.
some participants who are not, who are just taking the courses, who are not registered by paying any fee, so the assignments will be available for them and some certificates they may get. But for the proper registered students, they will have to give exam.
Yes, sir. I have
So
registered this one
you
for
are, so
exam.
you are registered, so you will be notified. And
Yes, sir.
I
Okay.
guess you have to go to some center and give your exams.
Okay. Okay. Sir, which are the points I have to concentrate?
But you will get the instructions.
Yes.
Say.
Which are the points I have to more focus, sir? Like all weeks video, like revision before going, sir. Like downloaded videos or like all previous year
What you can do? Yes. So you already have that one book of notes by the professor. So you can.
Yes, sir.
That book is basically the transcript of their lectures. So you can go through that, and I suggest you to go through all the assignments.
Yes.
This year, previous year, and that will be enough, because your main exam will be again in the same form, the objective type questions and all. So if you cover all these questions, all the assignments, so that will be more than enough.
Okay, sir.
Because there is no kind of descriptive question papers and all. Question pattern will be remain same.
Okay, sir.
Okay, so we are at the time of concluding the session. So if nobody have any other queries, I may ask to conclude this session. So thank you again.
Sure,
yeah, sure. So thank you again for joining the session and making the session successful. And this time the audience is quite good, interactive, and this session is going to be a successful till the end of the course. So I thank you all again, and I would like to conclude the session. Have a good day, and we will meet at the same time in next week, the Tuesday, 7 p.m.
sure. Thank you, sir. Thank you very much, sir.
Okay, thank you.
Thank you, sir.
Yeah, thanks.
Thank you, sir.
Welcome.